Okay, so here we have another problem. Um, I have this structure, rather unusual looking structure right here. If we look to see what we have three right triangles, and I'm hoping that you can see this in 3 dimensions. I have one right triangle here on the ground, and then I have 2 other triangles that are leaning against each other and also making contact with this triangle on the ground right here. And you can see the 3 right angles here, 1, 2, 3. And we're given some numbers. We're told that this side length here is 17. This long side of this triangle is 10. And this vertical height here is 8. It's an 8 right there. This is this height. We're asked to calculate this value here of x, which is the long side of this triangle here that's on the ground. Okay, so we're going to use the Pythagorean theorem again to calculate x, but we know that in order to do that, in order to calculate this side, we need to know 2 other sides. We need to know this side here and this side here. Here and here. At this point, neither have this side or this side, I'm going to have to use my other triangles to calculate these 2 values first. So I'm going to start here with this triangle with long side 17, and I'm going to label this unknown distance here. Let's call this A. And while we're at it, let's call this distance here B. That's this side length here. So let's start with this triangle, setting up my Pythagorean theorem, which I'm becoming pretty familiar with now. I have that A squared plus 8 squared is equal to, that is 17 squared. Continuing, that is A squared plus 8 squared is 64. And that is equal to 17 squared. To take out my calculator, I have that 17 squared is 289. So this here is 289. Rearranging this equation, subtracting 64 to the right-hand side, I have that A squared is 289 minus 64. That gives me a value of A squared. If I'm not mistaken, that would be 225. And therefore, A is the square root of 225, which is 15. And so I have a value here of A, for A of 15. Let me just put that in real quick. So this value here is 15. Okay, so that's the first part done. Let's move on. Draw a line under this. Here, let's work over here. We're now dealing with this triangle. That is this triangle here. Again, my Pythagorean theorem, applying it, tells me that that would give me 8 squared plus, this length is B, so that would be B squared is equal to 10 squared. If I multiply this out, I get 8 squared is 64 plus B squared is equal to 100. And then subtracting 64 to the other side, I get that B squared is equal to 100 minus 64. Therefore, B squared is equal to 36. B is therefore the square root of 36, which is 6. And so, put that in, enough room here. I have that B is equal to 6. So I have A 15, B 6. And I'm now in position, now I have enough information that I can calculate this value here of x. the two legs of my triangle, 15 and 6. I want the long side, that's x. So again, applying the Pythagorean theorem a third time to this bottom triangle, I have that 15 squared plus 6 squared is equal to, that side length is x squared. 15 squared, we just had that, that's 225, plus 6 squared, we know that that's 36. That's equal to x squared. 225 plus 36 is 261. So I have that x squared is equal to 261. And therefore, x is equal to the square root of 261, which simplifies to 3 root 29. So 9 times 29 is 261. So 29 times 9, I can take out my 9 from underneath the square root sign. It becomes a 3. So 3 root 29 is my answer. I can tell you that that gives me a value of x. Put it over here. This is approximately 16.2. Which again, just checking my values, here I have 15, here I have 6. So 16.2 is a reasonable answer. And I'm happy that I haven't made a mistake. That is correct. And that's how we would go about solving this problem, using the Pythagorean theorem. Okay, again, it was just to play it 3 times on this occasion, but it was only a matter of identifying the right angle triangles and applying the Pythagorean theorem properly. And that got us our answer. Okay, hope this was helpful.